Hello and welcome to the Unit 4 Section 3 video on transformations and triangle congruence. So we've been talking about triangles in this unit, and you've gotten a little bit of an introduction to triangles and how they work, and now we're going to start comparing triangles and how we can describe comparing two triangles. And the way we're going to be focusing on here for much of the rest of this unit is in terms of congruence. So if we have two geometric figures that are congruent, then they are the same size and they are the same shape. Now, corresponding angles and corresponding sides are the ways in which we're going to describe congruent triangles. Corresponding angles and corresponding sides are in the same position in polygons with an equal number of sides. Two polygons are congruent polygons if and only if their corresponding angles and sides are congruent. So therefore, triangles that are the same size and the same shape are congruent. So here's an example of what two congruent triangles look like. We have triangle ABC being congruent to triangle DEF. The corresponding angles are A is congruent to D, which is indicated by one angled curve here, or one angled tick mark. B and E are congruent, which is indicated by 2, and then C and F are congruent, which is indicated by 3. Similarly, we can say we have three corresponding sides. AB is congruent to DE, which is indicated by 1 tick mark, BC to EF, which is indicated by 2, and AC to DF, which is indicated by 3. In a congruent statement, the order of the vertices indicates the corresponding parts. So, in other words, the way we write our corresponding or our congruent statement, it matters what order you put the letters in, because the angles all need to match up. The vertices of the triangle all need to match up based on which ones are the same or congruent. So let's take a look at example 1 here. If that is the case, then given triangle ABC is congruent to XYZ, we're going to name the three pairs of congruent sides and the congruent angles. Well, since A is the first one in this name and X is the first one in this name, we can say that angle A is congruent to angle X. Similarly, we can say angle B is congruent to angle Y because they're both in the middle, and angle C is congruent to angle Z because they're both the last letter in the names. You can do the same for talking about the sides. So AB is the first two letters. So side AB is going to be congruent to side XY because that's the first two letters in the other triangle name. BC is going to be congruent to YZ because they're the second and third letter. And then we can do AC is congruent to YZ, or I'm sorry, XZ, because it's the first and last letter with the middle letter left out. Example 2 works very much the same way. Angle X is congruent to angle N. Angle Y is congruent to angle P. And angle Z is congruent to angle Q. XY is congruent to NP. YZ is congruent to PQ. And XZ is congruent to NQ. Okay? In example 3, we have two triangles shown, and we're told that they are congruent. Which of the following statements must be true? Angle A is congruent to angle D. Well, let's see. We have angle A here, which is between tick marks 1 and 2. Angle D is between tick marks 1 and, well, we're assuming 3 here. Let's go ahead and mark this as 3. Okay? So these are obviously different angles. In fact, let's mark our diagram first. That will make getting the answer a little bit easier. So let's make angle A, which is between 1 and 2. We know it's going to be congruent to E, which is between 1 and 2 here. B is between 2 and 3. So between 2 and 3 we have F. And that leaves the third angle as the one being congruent here. Okay? Let me clean that up just a little bit. Okay, so angle A and angle D, obviously not the same angle. Angle B and angle E, again not, because this one's got 2, this one's got 1. AB has 2 tick marks, DE has 1 tick mark, so that's not it, so it's got to be D. BC has our 3, FD also has our 3, so the answer here is going to be D. All right, let's take a look at example 4. Again, we're going to mark what we know. Well, obviously, we've got all of our sides marked. Angle X is going to be congruent to itself because vertical angles are congruent. And that is indicated by the fact that it's between 1 and 2. Here it's between 1 and 2. Between 2 and 3, I'm going to mark this one. Same thing over here. Between 2 and 3, I'm going to mark that here. And then F is going to be congruent to T. So now that we have everything marked, let's just see which congruent statement works. XSF, so 1, 2, 3, is congruent to XTG. So it should be 1, 2, 3. 1, 3, 2. That's not going to be it. XFF, so 2, 1, 3, is congruent to GXT. GXT, 2, 1, 3. Okay, we found our answer. It is B. And you can check the other two for yourself to see that they are not congruent statements. All right, for example 5, if RST, triangle RST, is congruent to triangle XYZ, which of the following is not necessarily true? Well, let's write out our statements here. Okay, we know that angle R is going to be congruent to angle X. We know that S is going to be congruent to Y. We know that T is going to be congruent to Z. We also can say that RS is congruent to XY. We can say that ST is congruent to YZ. And we can say that RT is congruent to XZ. So this will help us out as we go through our choices. So angle R is congruent to angle X. Well, we wrote that one down, so that one is most definitely true. Angle T is congruent to Z. That's written down here, so that is true. RT, which is here, is congruent to XZ. We wrote that one down, so that is true. SR, which is here, and YZ. Different congruent statements, so this one is not necessarily true. Now, why do we use the term not necessarily here? Because it could be true. What if all the triangle side lengths are the same? In that case, it would be true. But we don't know that's a condition. So that's the only one where we can't say is true in all situations for every triangle or every pair of triangles by that name with this congruent statement. All right, let's take a look at example 6. In the diagram, triangle TJM is congruent to triangle PHS. So we're going to complete the statements here. So if this is the case, we know that we have angle T is going to be congruent to angle P. So this one must be 73 degrees here. So I'm just making some notes based on what we know. J is going to be congruent to H, okay, and then M is going to be congruent to S. So M and S are both going to be 48 degrees. Well, we can determine some other things as well based off of this, okay? So let's first of all see what we're being asked. Angle P is going to be congruent to what? It's going to be congruent to angle T, because P is first in the second triangle, T is first in the first one. So angle P is congruent to angle T. The measure of angle M we found is 48 degrees. MT, which is here, is equal to what? Well, let's see here. Is it equal to 5? Well, we have SP, which is the last and the first. MT is the last and the first. So, yes, this must also be 5 centimeters. So, MT is 5 centimeters. Remember, when you are given units, make sure you include your units. JM is going to be congruent to segment HS. The measure of angle P we found is 73 degrees. And triangle HPS, which is the middle, first, and last, or 2, 1, 3, is going to be congruent to triangle 2, 1, 3, JTM. And then in example 7, given that we know that these two triangles are congruent with this congruent statement, we're going to find the values of x and y. So we know that angle D and angle A are congruent to each other. So angle D is 5x plus 2. Well, before we get there, if we know that these two are congruent, let's put in this intermediate step. Then the measures have to be the same. Now let's plug in. Measure of angle D is 5x plus 2. The measure of angle A is 87. Subtract 2 from each side, and you get 85. And 5 goes into 85 17 times. We also know that angle C is congruent to angle F. So therefore, the measure of angle C has to be equal to the measure of angle F. So the measure of angle C is 3y. Measure of angle F is, well, we have to find out what that is. Well, we know that the sum of the triangles is going to be 180. If we subtract the other two angles, then we know we have minus 87, because we know that A and D are congruent. If A is 87, so is D. And we're also going to subtract the 42. 3y is equal to 51. So as it turns out, y is also going to be 17. All right, in example 8, given that triangle GEO is congruent to triangle FUN, because geo is fun, right? Let's the measure of angle E equal 3x minus 4, the measure of angle F equal 2x, and the measure of angle N equal 20 minus x. So first we're going to draw and label a diagram. So we're going to have triangle GEO, and we're going to have triangle FUN, and we're going to label these in the same order as what our similarity statement, or I should say our congruence statement, tells us. Okay? So let's mark up our diagram. We know that angle G is going to be congruent to angle F, angle E is going to be congruent to angle U, and angle O is going to be congruent to angle N. We also know that GE is congruent to FU, EO is congruent to UN, and OG is congruent to NF. So knowing all of this, we know that angle E is going to be 3x minus 4. We know that F is going to be 2x. And we know that N is going to be 20 minus x. So now we've labeled everything that we have. Now let's list all 6 pairs of congruents. So we have angle G is congruent to angle F. Angle E is congruent to angle U. And angle O is congruent to angle N. Similarly, GE is congruent to FU. We also have EO is congruent to UN, and we have OG is congruent to NF. Now let's solve for x. Well, how do we do that? Well, if E is congruent to U, then this must also be 3x minus 4. And if we have all 3 of our angles, we can set them equal to 180 degrees. So we're going to have 2x plus 3x minus 4 plus 20 minus x is going to be equal to 180. And from here, we can solve for x. So you combine all your like terms, you're going to get 4x plus 16 equals 180. 4x, when you subtract 16 from each side, is going to be 164. And so x is 41. All right, now let's move on to drawing and identifying transformations. Recall, a transformation is a change in the position, shape, or size of a figure. Translations, reflections, and rotations are considered rigid motions. We call them rigid motions because the size of our figure does not change. Okay? So, a rigid transformation can be used to prove 2 figures are congruent because the size doesn't change. They preserve the side and angle measures, both. So let's talk about which triangles are congruent in this example. Well, let's take a look at ABC. We go up 2 and over 2, up 1 and over 3, down 3 and over 1. Okay, so we have a side that kind of goes across 2 diagonals. This one has that, but it also has a second one. So we know that this one is not going to be congruent to ABC. We also know that the other 2 are not going to be congruent to ABC because there is no 3-to-1 slope for either of these. So ABC is not congruent to anything. DEF is also not congruent to anything, so that leaves these 2 triangles. We have triangle KLM is congruent to, and now we have to be careful and make sure we name the right thing. So we go diagonally 2, down 1 and over 2, and then the straight edge. So we're going to do the same thing. Diagonal 2, over 1 and over 2, and then across the straight edge. So GJH. In example 10, we are going to show that the triangles are congruent, and here we have a little bit of help. The intermediate steps are drawn for you already here. So what we have here is we know that they are congruent because it preserves the shape. So we have a translation up by 2 units. And then we have a reflection across the y-axis, because you can see it flips across the y-axis, so that's a reflection. And then we have it translated to the right by 2 units. So since we're able to move this figure from one position to the other through just a translation or reflection, then we have done all rigid motion, which means the 2 triangles are congruent. In example 11, which triangles are congruent? So again, we're going to pick out which ones preserve the same size and shape. Well, these are not that difficult to determine. You can see A, C, and F all have the same size and shape. So triangle A is congruent to triangle C, which is also congruent to triangle F. So that takes care of those 3. Then let's take a look at D. We have 2 sides that are 2 units just straight across the grid, and then 2 units or 2 grids at a diagonal. G does the same thing. In fact, G is oriented the exact same way. E is the same, it's just flipped. So we have triangle D congruent to triangle E, which is congruent to triangle G. So that leaves triangle B, which is not congruent to anything. So triangle B is not congruent to any other triangle. All right, example 12. We're going to determine which pairs of triangles are congruent and describe the set of transformations that proves it. So let's take a look at what we have here. BCD looks very much like FGE. Okay, so check the vertices, make sure you line it up. BCD is congruent to FGE. In fact, it's triangle FGE. Okay, and this is because it's rotated 180 degrees. About the origin here. All right, KLM looks very much like NOP. So we have KLM is congruent to NOP. And again, make sure those letters line up. This is the correct ordering of these letters. And in this case, they are oriented the same way, so that actually makes it a little bit easier to line up the letters. We have a couple of translations. Translated up 7 and right 8. And then finally, we have QRS and TUV. In fact, it should be QRS and UVT if we're going to write it in the correct order. So triangle QRS is congruent to UVT. And what we have happen here is we have a rotation of 180 degrees. And that rotation happens about the origin. So if we rotate it about the origin by 180 degrees, then you're going to end up right here, okay? It would be right here. And then we have to translate it up by 2 units and to the right by 6 units. So we have it rotated 180 degrees, again, about the origin. and then translated up to and right 6. All right, so that finished us off this section on congruence and transformations, and more specifically, rigid transformations, since we are talking about congruence here. All right, coming up in the next section, we're going to talk a little bit about proving congruent triangles.